Welcome to the Explainer. You know that feeling, right? The dreaded frozen web page? Today, we're going to look at exactly why that happens and how a really cool framework called wffweb, using a game-changing new feature in Java, can pretty much make that frustration a thing of the past.
So let's start with a question that I think we have all screamed at our screens at some point. Why do some websites feel so clunky? You click something, you try to type in a box, and the whole page just stops. Nothing. You can't click, you can't type, you just have to sit there and wait. It is so frustrating, right?
And a lot of the time, it's not actually your internet. The real culprit is something called UI gridlock. Think of it like a traffic jam on your screen. One slow car, or in this case, one slow part of the page, is holding everything else hostage. And it just brings your whole experience to a screeching halt.
Okay, so here's how we're going to break this down. First, we'll really dig into what UI gridlock is. Then, we'll look at the old way of fixing it, using something called asynchronicity. After that, we get to the really cool part, the virtual thread revolution. And finally, we'll see where this stuff actually makes a difference and what it means for the apps you'll be using tomorrow.
All right, first up, the user interface gridlock. Let's really get into the nitty-gritty of why you end up just staring at a frozen screen. The example from the source material is perfect, and I bet it's happened to you. Picture this. You're filling out some big, long form online. You click on the first name box to start typing, and nothing. The cursor won't even appear. Why? Well, it's because way down the page, that little country drop-down menu is trying to load a massive list of every country in the world, and the entire page is just stuck, waiting for that one little thing to finish.
So that's the problem. How do we fix it? How do we break that gridlock? Well, the traditional solution is something called asynchronicity, basically using more than one thread to do the work. And this is where it gets really clear. Look at the left side the synchronous way. It's a one-lane road. The header has to load, then the drop-down data has to load, and that's our traffic jam, and only after that does the footer load. The whole time your screen is frozen. But now look at the right. The asynchronous approach is like opening up a new lane. It loads the header, and then it says, hey, you, separate worker, go get that drop-down data in the background. Meanwhile, the main lane keeps moving, loading the footer and showing you the page immediately.
And this is the whole point, right? It's all about how it feels to the user. To you, the page just loads instantly. You can start typing your name, your address, whatever. And in the background, that country list is still filling up. But you don't care. You don't even notice. The app just feels fast and responsive, even though it's still doing heavy lifting behind the scenes. Okay, so multi-threading sounds like the perfect solution, right? Well, there's a catch. Those traditional threads, they're heavy. They take up a lot of memory, a lot of CPU power. You can't just spin up thousands of them without your server grinding to a halt. And that brings us to the real revolution here.
Starting with Java 21, we got something completely new, virtual threads. And they are an absolute game changer. They were built specifically to get rid of that heaviness, to make doing lots of things at once super cheap and super easy.
So just how big a deal is this? Well, the wffweb framework documentation puts a number on it. We're not talking about being able to run a few dozen extra threads or even a few hundred. No, we're talking about running millions of them on a single machine. That's a completely different scale. And that's the key takeaway, right there. You can now create a tiny, lightweight virtual thread for every little thing that needs to happen at the same time. That dropdown, it gets a thread. A chat box updating, it gets a thread. A stock ticker, it gets a thread. You can do this for everything without even thinking about it, and the system won't slow down. It allows for a level of responsiveness that was just a pipe dream before. This really puts it side by side. Think of the old platform threads like semi-trucks. They're powerful, but they're big, expensive to run, and managed by the operating system, the highway patrol. You can't have millions of them on the road. Virtual threads are more like delivery drones. They're managed by Java itself, the warehouse manager. They're super lightweight, you can have millions of them, and for small, fast jobs like updating a UI, they are absolutely the perfect tool.
Okay, so this tech is awesome, but where does it really shine? What kinds of apps get the biggest boost from this stuff?
Well, the docs for wffweb point to high-performance applications. We're talking about places where speed and real-time data aren't just nice-to-haves, they're critical. Think about your banking app, or a stock trading platform, or a dashboard that's supposed to be showing you live data. In those situations, a frozen screen isn't just annoying, it could actually cost you money or cause a huge problem.
So this isn't just about making old apps a little faster.
This is a fundamental change. We're moving away from a world where we build UIs that block and make you wait to a world where everything can happen at once. And that, well, that opens the door to building completely new things.
So, when you boil it all down, here's what's happened. We've completely flipped the script. It used to be that the user had to wait for the application. Now, with tools like virtual threads, the application waits for the user. It's always ready, always responsive. And that leaves us with a really exciting question to think about. Now that we're not held back by these old limits, what comes next? What kind of amazing, complex, data-heavy apps can we build now that they can still feel instant? Thanks for joining this explainer.